Hello, welcome back to Project Master Podcast. We're going to talk about 7 patterns. We're going to talk about 7 patterns of AI. Let's start with conversational pattern. Conversational pattern refers to conversation and human interaction pattern. Machines and humans are going to interact with each other. They're going to interact using a particular natural language or a conversational form of interaction with variety of communications that will happen, including written communication, text communication, voice communication, image forms. This is going to include machine to human capabilities, human to machine capabilities. There's going to be back and forth conversation between human and machine. There's going to be back and forth interaction between human and machine. The objective of this pattern is machine is going to interact with humans exactly the same way how humans interact with each other. Examples of conversation patterns: there are chatbots available, voice assistants, content generation, sentiment or mood analysis, machine translation, NLP task, namely natural language processing task, are all examples of conversation patterns. NLP is a field in computer science that is applied in AI. It meets the challenge of getting machines to understand and communicate using the language that humans generally use. NLP is an umbrella term. It includes ideas of NLG as well as NLU. NLG stands for natural language generation, NLU stands for natural language understanding. You're going to use AI systems to create written text. You're going to use AI systems to create spoken text in a language that a human can understand. NLG is considered a subset of NLP and it aids the concept of text to speech, where semantic understanding comes into picture. Semantic understanding of the speech being generated comes into picture. Natural language understanding, where you're going to use AI systems to enable machines to understand written language. You're going to use AI systems to enable machines to understand spoken human language. NLU is a subset of NLP and is going to aid the concept of speech to text. It will always provide a better level of understanding of the text, including the particular intent of the text, the parts of the speech. It is also going to deal with extraction of associated entities. Automatic speech recognition or speech recognition is going to transform the sequence of sound waves into a string of letters. It's going to transform the sound waves into a string of words. It is considered as an important component of natural language understanding. Speech recognition is going to provide the ability to identify the words, the intent, the structure, and the components of speech of spoken language. Speech recognition is a component of speech to text, as well as it can provide high-level functions for applications like chatbots, voice assistants. Automatic speech recognition, ASR, speech recognition and speech to text are often used interchangeably. Content summarization is also part of conversation and human interaction pattern. You're going to use AI and ML to produce concise summary of the text bodies or concise summary of the content in a way to understand the meaning, or you're going to provide a short analysis so that humans are able to consume them. Content summarization analysis is going to use NLU so that you'll be able to extract the key information and you're able to generate a short summary or an overview of the content in addition to semantic summary of the content. Sentiment, mood analysis, intent analysis, it is a process of identifying opinions that are expressed in text. It's a process of categorizing the opinions that are expressed in text in order to determine whether the individual's attitude is going to be neutral, or is it going to be positive, or is it going to be negative. NLP technology is being combined here. Sentiment analysis is going to help organizations to analyze customer feedback. You will be able to find out what are the topics trending. You'll be able to identify what are the top complaints. You're also able to track what are the trends which are critical over time. You're able to gain a complete picture of the customer's voice. You're able to analyze the sentiment, which is important to understand what is going to be the individual's intent who is communicating really. What is going to be the intent of the individual who is communicating really means. Let's move to the next pattern called recognition pattern. The objective of this pattern is to have machines identify the real world, have machines understand the real world, and you're going to have the machines understand the unstructured data. You should be able to identify the images, you should be able to understand the images, the sound, the video, the faces, the gesture, handwriting, etc. Examples of recognition pattern: very popular facial recognition, object detection, sound recognition, text recognition, handwriting recognition. AI systems can be trained so that they are able to recognize each and every aspect of unstructured data. Image classification and categorization is also coming to picture here. Facial recognition is actually a particular case of image recognition. Handwriting recognition or text recognition is also part of a recognition pattern. It refers to the computer system's ability to understand handwritten content from the documents and digital sources. You're going to train the system on images of any unstructured data. Let's say, for example, you want to check imaging for deposit, you want to do intelligent document processing, you want to analyze the documents, you want to interpret what is the handwritten content here. Gesture recognition and motion analysis is also part of recognition pattern. Computers are able to capture the human gestures and then interpret them as commands. You want to create an engaging retail experience. You want to immerse the shoppers with the relevant content. You want to enable them to try on the various clothing accessories. You want to help the surgeons virtually grasp the objects on a particular screen. You want to interpret the sign language. You also want to translate the sign language. All this is possible through the recognition pattern. Sound and audio recognition is also following part of recognition pattern. Music recognition systems can identify and recognize songs. These systems are capable of recognizing music, instruments, musical patterns. You want to recognize the speech in different language. You want to identify animals based on their sounds, their noises, based on specific songs. All these are all part of sound and audio recognition, which falls under recognition pattern. Computer vision is an application of machine learning. Computers have the ability to understand visual inputs. There are many components of computer vision, especially image analysis, object detection, object recognition, image segmentation, event detection, object tracking, image indexing, 3D scene modeling, image acquisition. You also have the ability to restore images. Hyperpersonalization pattern is going to use machine learning to develop a individual's unique profile, and it's going to use that profile. It's going to have that profile learn over a period of time. It's going to have that profile adapt over a period of time for a wide variety of purposes. You want to display customized content, you want to display relevant content, you want to recommend the relevant products for the customer. You can provide personalized recommendations and guidance. The objective of this pattern is you should always treat every individual as an individual. The use cases for this particular pattern are behavior profiling. You want to provide personalized finance capability, you want to provide personalized medical facility, you want to provide personalized educational facility, personalized learning capability. Let's say that you want to develop a profile for a particular user. All these are examples of this pattern. You're going to use the computer system so that you're able to customize the offerings. You're able to tailor the offerings based on specific user attributes. Personalization means generally you're going to group the users into similar buckets. You're going to group the users into similar categories. Personalization is used to tailor the products. It's also used to tailor the services. You can tailor the content to the specific user needs. Applications include advertising, sales conversion, marketing, branding, product selection, social media views. The ads that you are going to see when you search on a Google website, the content you're going to see on the social media, all these are actually examples of personalization where they're going to deliver the custom information based on your profile and other factors. Google search algorithm, Twitter or Facebook algorithms or YouTube algorithms, they use personalization. They also use recommendation algorithms. What you see is not going to be the same as what any other individual else sees it. Recommendation systems are computer systems that is going to provide suggestions for a particular content or for a particular product or for a particular service, or it's going to provide choices that a person might be interested in. It's going to monitor the person's behavior. It's going to look into the customer profile. AI systems can provide recommendations. It's going to recognize the pattern. It is going to use predictive analytics approach. Recommendation systems examples might include you want to suggest goods to purchase, you want to suggest the music to listen. Personalization means you're going to provide the specific choice that the customer wants, and recommendation system means it's going to make those choices available and record the choices so that it can improve future recommendations. Hyperpersonalization is one of the 7 patterns of AI that's always focused on machine learning approaches that will develop the individual's profile, which will evolve over time rather than categorizing them or bucketing them, which is in the case of personalization. It's not going to group the individual into a particular category. The objective of this pattern, as we discussed, it is going to treat every individual as an individual. Patterns and anomalies is a pattern where machine learning is good at recognizing pattern. You're going to train the system. It can easily detect patterns. It can easily detect things. There are various examples of pattern and anomaly detection. Fraud detection is an example. Finding outliers in big stock of data is an example. IoT analytics, sentiment analysis, cybersecurity applications, time series data are all examples here. Machines are very good at looking into the data to find insights, to find patterns, to find data groupings. Machines can find patterns and anomalies that humans are not able to see. Predictive analytics and decision support. It's a pattern which is going to use machine learning and cognitive approaches in order to understand how to take the existing behavior as an input or take the past behavior as an input, and using this input you want to predict future outcomes. You want to help the humans take better decisions about future outcomes. You're able to achieve this by using insights that are learned from current behavior or past behavior based on interactions as well as based on data. The objective of this pattern is you want to help humans take better decisions. Predictive analytics is going to work on past data and current data and make predictions. It is very useful to find patterns in data to spot potential fraud. It can be used for recommendation engines. It is also used in making predictions with time series data. Some of the examples are cybersecurity applications, behavior targeting, fraud detection, situational awareness, predicting the behavior of the individual, predicting failures, recommendation engines. You want to search and retrieve, it is going to assist searching and retrieval operations. You want to create an intelligent knowledge base, you want to predict a particular number or value. Let us say you want to focus on dynamic pricing, you want to focus on predictive pricing. All these are examples of this particular pattern. You want to identify trends that could happen in the future. You want to provide recommendations, you want to find out potential issues. You want to make predictions on the new data based on the patterns that you have learned from the current data. Predictive analytics will definitely improve forecasting. It can improve planning around supply chain forecasting, reducing understock or overstock of goods and services. It can predict the purchasing pattern of the individual in real time and forecast what is going to be the future inventory needed for business. Weather forecasting is also possible. Predictive maintenance is a good example here. Financial trading also comes into picture. You are able to predict the markets and find financial trends which can be leveraged by the corporate companies. You're going to analyze the business data and you're going to make business decisions. You can provide relevant information which is going to be useful for taking business decisions. Insurance claims, loan approval systems, autonomous systems. We're talking about a physical software, a virtual software which is able to accomplish a task. It is able to interact with surroundings. It's able to perform the goal with minimal human interaction or with zero human involvement. Examples are autonomous robots, autonomous software systems, autonomous business process, autonomous vehicles. It also includes autonomous decision making. The goal is to minimize human labor. Autonomous systems are going to be measured by the degree to which the humans get involved in the system, right from level 0 till the level where it requires zero human involvement. So there are at least 3 or more levels here. Autonomous vehicles have 6 levels of autonomy, level 0 being fully operated by human to level 5 being autonomy achieved, where you don't require any human involvement. Level 1 to 4 will definitely vary based on the degree of autonomous operation. Level 0 means zero autonomous features. Level 1 means you can handle a particular task like braking. Level 2 means the cars will have at least 2 automated functions. Level 3 means you can handle dynamic driving task, but there is still going to be human interaction. Level 4 means officially you are making it as a driverless, but it's going to work as a driverless car in specific environments. Level 5 means you can operate entirely on own, meaning the car is able to operate entirely on its own. It does not require human interaction at all. You can automate software. This is where RPA comes into picture. You want to automate repetitive tasks previously handled by people. RPA is an alternate solution for outsourcing business process, and it's an alternate solution for APIs. In RPA, there are two terminologies: attendant bots, unattended bots. Attendant bots means it's a bot that's going to help the human. It's a software automation that's going to sit next to human. It's going to assist the human in performing tasks so that the productivity gets boosted. Example, front office task. The bot is going to collaborate with the employees. The bot is going to collaborate with teams. Employees are going to trigger a particular bot and interact with the bot as it helps. Attendant RPA bots wait till it gets activated by the employees whenever they are needed to provide the required assistance in the process. Unattended bots means these bots are going to run in the background process. It is automating the background process. It's a software automation that's going to operate in the background. Unattended RPA bots work independently. For example, back office operations, back office process. It is going to operate on a predefined schedule, or it can be automatically triggered by a particular logic in the process flow. Low code is a terminology where non-developers and citizen developers can build software applications with minimal coding effort or zero coding effort with minimal coding knowledge involved. No code means there are platforms that are available especially for non-developers and citizen developers where you can build custom software applications without having any knowledge or even the ability, or does not require any effort to code. You can add AI to RPA, and what we get is an intelligent process automation. There are 4 levels of intelligent process automation: level 0, level 1, level 2, level 3. Moving on to the next pattern, which is the goal-driven pattern. This is one of the 7 patterns of AI. Goal-driven systems use reinforcement learning. It is used in real-world games. The goal is to find the optimal solution to a problem, and you're going to use the trial and error method here. There are hidden rules in a particular game, and that can be easily discovered through machine learning. Goal-driven systems are able to be the best experts in their own games. Examples, you can use them for scenario simulation, you can use them for games, you can use them for resource optimization, you can also use them for bidding, real-time auctions, where you want to solve the problem iteratively. Goal-driven systems are going to be good at finding the optimal solution. Applications that work best are generally simulation, resource optimization scenarios. It's also going to be used for optimization. The AI research company DeepMind was acquired by Google, and through reinforcement learning approach, systems like AlphaGo, AlphaZero were created. AlphaGo is the application created by Google's DeepMind, designed to play the game Go based on advanced concepts of reinforcement learning technology and deep learning technology. AlphaGo was able to beat the best player in the world in the game of Go. AlphaZero is also an AI application that was created by Google's DeepMind. It was able to play games surpassing human ability. It can play games within 24 hours of training. It was able to beat AlphaGo, the previous system. You need to combine the patterns of AI for a particular application. There are applications where more than one pattern is being used. You need to understand which pattern you're going to use. It will help you understand what are the data requirements based on the pattern, what are the algorithms that you need to select, and how do you successfully run and iterate these models on your product. Let's say you have a AI chatbot that's going to help the customers navigate and answer questions about different goods and services. You're actually using an hyperpersonalization pattern here. Chatbot is able to pull the data on that particular customer. It's also able to answer the customer questions. It's able to provide suggestions for a particular product. Conversation pattern is also used here. Chatbot is able to converse with the customer in the language that humans can understand. Anonymization pattern is used here. Chatbot is able to look into the large data sets. It's able to quickly find patterns in the customer's buying choice, in the customer's buying requirements. Let us say you have an application which is going to take a snap of your body parts and is going to tell you whether you are suffering from a particular disease and you need to approach a doctor or not. What is the pattern used in this application? You're using a recognition pattern. The application is able to look into the photo and identify, is able to understand what that particular image means. You're using the pattern anonymous pattern here. You're able to recognize the patterns. The application can quickly find out if there is any particular spot that will require special attention or there is any outlier that is present. The application also using a conversational pattern because only through the application the user is able to ask the basic queries and is able to get the answers in a conversational manner. If you take the example of a collaborative robot, it's a possibility that it can have multiple patterns where the collaborative robot is going to move the boxes and is going to help the people load the boxes into the truck containers. The collaborative robot, which is called cobot, is going to use autonomous pattern because it is able to move things around without the help of people. It is using recognition pattern because it is able to detect the objects and it is also able to detect the obstacles in front of it, making sure it is not going to bump into the humans. The application is also using goal-driven system pattern as the cobots are able to come up with an optimal solution, come up with the best path, come up with the optimal path so that they are able to move through different floors in the factory. Cobot is also using conversation system pattern. Cobot is able to converse with humans. It is using conversation pattern also. So if you look at this particular application, autonomous pattern, recognition pattern, goal-driven pattern, conversation pattern is being used. Hence, an application can have more than one pattern. We have covered all the 7 patterns of AI. We have come to the end of the podcast. Hope the knowledge is valuable. Thank you for tuning in.